take their mean. So if you are lucky, their mean may be equal to what? 3.5. Their mean may be less, or what? Or more. So you want to find out this difference in mean between the true and the 3.5. Is it a significant one or not? So what I'm trying to say is that, you see, there's always a standard of measurement. Let's take even blood pressure. Blood pressure, you have, I think, 80/110 or so, 120/80 as the what? As the normal, blood pressure. Then you now collect blood pressures from individuals. Then you compare the ones you collected against the measurements to find out if they are the same, if they are more or less. So this morning, before we go further, I want us to just check in our field or area. Do we have any benchmark that we can use? That this one is known worldwide as the figure that you cannot compare your own readings with. Like engineers now, they will tell you in the mixture of sand, cement, and water, there's a particular ratio. Any engineer here in this class? Which of the engineers are you? Civil. What's that ratio of sand, water, and cement? The standard one.
Let's go.
1:4. And do you know that it's not always that you get that? Some people slightly may go above, some slightly may go below. So you now compare your own with the known what? Standard. Any other person that can give us any example from this or our own field where we have a standard which we call the hypothesized mean now, and then you can now carry out a research, get your own results, and compare your own readings, the mean of your own reading with the standard. Let's take one or two. Yes, ma'am. Okay. 1.90. Wow. So,
Whatever
this with, yeah, I know Nigeria can never be that. What is Nigeria's? So everywhere in the world.
Why?
More or less. Okay. All right. So now we can get 1.9. Okay. So that's 1.9 can stand as our what? Hypothesized mean. So people call it the assumed mean. Is that okay? Any other example from any other field? Okay, no any other example. All right. So now let us look at the conditions. We said that under parametric tests, there are conditions that must be met. You can use any parametric tests. Still on that page, you see those conditions. Statistics that is continuous. It means you can only use continuous data here, interval or ratio. Okay? That's condition number one. If you have data that are not continuous in nature, you cannot use these tests. Because on the test variable are independent. That is, each of those scores do not depend on each other. The scores of number one does not depend on number two, on number three, and so on. Okay, they are independent outcomes, independent scores. And you must pick your sample randomly from population. Is that okay? Like in this class now, if I want to pick 20 now, what I will do is to give all of you numbers. If you are about 30, everybody will have his or her own number. Then I have another way of, that raffle draw method. So I pick randomly.
With some
So pick randomly until we pick the desired sample size. Okay?
Saba or Saba.
It's your friend to you, or somebody is who pick randomly on this test. All right. I hope we are getting. Now, another condition here, as we all know, is that our data must be tested for normality. Test, be sure that the data is normally distributed. I talked about this homogeneity of variance, that is one of the conditions. But here, I don't think it's important because the condition here says that you have two samples. And in that two samples, the variance in the two samples must be what? Equal. But here we are talking of just one sample. Therefore, that homogeneity of variance is not important here. And then the last one is the no outliers. There must be. All right. So, any question on this brief background information? That have two means here. One sample. The first mean is the one called the true mean. Okay. Second mean is the one we call the assumed mean or the hypothesized mean. So the test here is to find out whether there is a significant difference between the true mean and the hypothesized or the assumed mean. So I don't have the test statistics here, the formula. So let's go straight to the practicals. Let's open our data. Yesterday we presented some data to you. So let's open that. And this test we have three types. There was one I called one sample, paired and independent. So let's open the one sample test. Okay, is that what I called it? Test one. Okay. right, so I've imported my data now. Oh, data is scattered. Is it this one? For pH sample. So you see what we have is this one. So we have 2 GPA, the high school GPA and the college GPA. So let's open this one sample. What is the maximum score here? Is it for high school? Is it 5?
Come on, what?
It's 4, right? And that is why we use 3 as the hypothesized mean, because we assume that for students that can score 3 out of the maximum of 4 is a good student. Okay, so that's why we are using 3 as the assumed mean. So the assumed mean here is 3. Now, before we start, don't forget the conditions that we must check for what? Normality. We also check for outlier. And what's the other one? That one I said is for when you have 2 data. So you forget about that one. The other one is it has to be a continuous data. It is continuous. And you know, the scores are independent. Doesn't have any relationship with themselves. So now the next test is for us to check if it's normally distributed and if we have outlier in the data. Let's quickly do that. The 2, let's check the 2 for normality and presence of outlier. What's the sample size?
No.
Sample size is 90. Please take note, sample size is 90. In picking your tests between the Kolmogorov and what's the second one? Sharp-Lewis. All right, I have my test already. What's our p-value? Or what test are we using? Let's start with that. Which of the two tests are we using? Kolmo-Kinikon. Okay, we are using Kolmogorov-Smirnov, right? So what is the p-value there? 0.05. No, that's not the result from the one I just did. Check again. I hope we can all do this. Is there anybody who cannot do this? 0.2 for which test? For Kolmogorov. So that's the right test. You know, that one says you test when the sample size is large. That's the test for large sample. N is greater than 50, right? Therefore, it means they are normally distributed, the two of them. I want you to confirm that they are both normally distributed. All right. They are both normally distributed. All right, so now let's take the test. We have set the hypothesis for the first one. The mean of high school GPA is not 3.0. H1 will now be that the mean is 3.0. Step number 2. Let the contract. Okay. Look up to see my movement. We started from analyze to compare means, and then to what? One sample t-tests. So you click on t-tests. We have our dialog box. The next step is to move your tests to the test variable. I'm too fast. All right. Thank you for telling me. You didn't talk before. You are not among those that said I'm fast. All right, let's start from the analyze. Well, I start by telling you that we have our hypothesis already. You can see the hypothesis there. The mean of high school GPA is not 3.0. That's our null hypothesis. Then second step, we said level of significance is 0.05. And then the third step, we started the analysis. So let's do the analysis again. All right. Analyze. From analyze, you go to compare means, and then you stop at one sample t-test. Can I continue now? All right, then you click on one sample t-test. When you do that, you have this dialog box. Then you move your variable to the test variable box. Then your test value is your assumed mean or your hypothesized.
So you need to get the final money. The mark.
Your test value, where you have that zero is your hypothesized mean. And from the hypothesis, our assumed or hypothesized mean is what? 3.0. You can just write 3 or 3, whichever one. But let's just write there. So it's not, we don't use 0 there. You must have your own assumed or hypothesized mean. And I've explained. Don't say because they say assume mean, you will not assume anything. Are we together? Don't say because the mean is called assuming, it is a standard somewhere. Like in this test now, standard for what? For good students. Okay? Over 4. Any student that can score up to 3 is a good student. It's just like if it's over 100. I think good students or good performance will start from 70, right? I know landmark will not. But here I know it's your test value, because that's the assumed. Because you are
Staff.
significant, therefore the confidence should also be 95.
Book can be. Okay. You get.
Click end by clicking.
Instagram. Click on Facebook and Instagram.
Okay. Our results. The test here is to find out if the difference between the true mean and the assumed mean, if it's significant or not. Now, we said it's 3. What is the true mean? Have you seen the true mean there? The true mean is 2.53 and so on. Let's report first. Huh? Okay, minus 0.46. All right.
You are there. You have page for people to see it. So that's why you be
True mean equals 2.54. Standard deviation equals 0.87046. T calculated for the manual use. All right, so let's start all over again with reporting our results. We said the sample size here is 90. The true mean is 2.54. Standard deviation equals 0.87.
just
Calculated equals minus 5.036. Minus 5.036. Degree of freedom equals n minus 1 equals 89. Equals n minus 1 equals 90 minus 1 equals 89. Degree of freedom, df, equals to n minus 1, okay, equals to 90 minus 1 equals to 89. See 90 there. Look at your n. So n minus 1 is 89. Let her ask question, because you refuse to ask. Let her ask. All right. N minus 1, 90 minus 1, 89. All right. Then the difference in the two mean, that's the difference between the assumed mean and the true mean, equals minus 0.46211. All what I'm reading here is here in your result. So I want you to follow the results. Mean difference. I'm on mean difference. Now check mean difference in your result. Have you seen it? So the mean difference there is minus 0.46211. All right, we have just report our results. We don't usually talk about confidence interval. No. For standard error, we said that for every analysis that we carry out in statistics, we always give space for error. There's always error. So that is error. The error in this test, because we are saying that the test is at 0.05, meaning that we are leaving 5% error. So what is that 5% error? So that is the error. So most times we are silent about it because we don't want to too much. But if you want to see the margin of error, just go to the standard error in the mean. So from now on, I want you to notice that for every analysis we do, there must always be that error. Okay? There's always space for error. And that is why we are not claiming to be perfect in our analysis. So I want us to reframe that hypothesis. Let's recast it in a way that we're going to understand. H0. There is no significant difference. There is no significant difference between the true mean and hypothesized mean. There is no significant difference between the true mean and the hypothesized mean. H1, there is a significant difference. There is a significant difference between the true mean and hypothesized mean. If I want to go a little bit technical or deeper, I will tell you that H0, X bar, X bar is a symbol for true mean, minus mu. Mu is another symbol for mean. So we can call mu the hypothesized mean. So we now say H naught X bar minus mu equals to 0. Mu is the symbol for hypothesized mean. X bar, X is the true mean. So now the difference between the true mean and what hypothesized mean is 0. That means there is no, that's indirectly, that's what it means. There is no significant difference. Then the H1 will now be X bar minus mu not equal to 0. So you will now write that X bar equals to the true mean. X bar equals true mean. Do you know how to write that mu? It's like U. You will now curve the mouth of the. Let me see it. You curve it. Okay. I think there's somebody from Mars here. Who is from Mars? Where are they? Ma, you know about mu now? That you that you curve. All right. So it's just a symbol, you know. So that's another way of writing this hypothesis. But the main hypothesis is that there is no significant difference between the true mean and the assumed mean. Okay? And that's what we wrote in that other way. All right. Now, let's interpret the results. Since P value equals to 0.000. You know, yesterday I showed you all those other zeros. So maybe there's still some things after this. .05. The null hypothesis is rejected. The null hypothesis is rejected. And the alternative accepted. We therefore conclude that I use that word we because it's a training. If it's your research, don't put we. It can be concluded that. So you state. There is a significant difference between true mean and assumed mean. You see, look at the difference. What we are saying is this difference is a significant one. Look at the students' performance, 2.5. It's not up to the benchmark, you know, for measuring good students. So it means that generally the students did not do very well, did not perform very well. That's the implied meaning of this our analysis, because their mean is what? Is way below the benchmark of what? 3. So if you are the head of department or the lecturer involved here, it means this call for what? Attention, immediate one, because that difference is a significant one. You cannot ignore it. I hope it's okay. Understand this. Now, question on this analysis before we take our class work. You want to draw us back? I've not looked at it. I only just acknowledge the ones I received. I've not looked at it. Don't worry, I will send this. I have your email. I will respond. Is that the question? We are saying ask question on this. You want to ask question? Because we rejected our null hypothesis. And how did we reject it? We use the decision rule. I gave you that decision rule since on Tuesday, if I can remember. And we even talked about it again yesterday. Null hypothesis. Yes. Your p-value there is 0.00. And it is less than 0.05. Therefore, you reject your null hypothesis. If your p-value is greater than 0.05, what do? You accept your null. Or you fail to reject. All right. Let it be on this one. And I said it categorically that the fact that we said assume doesn't mean to assume. Who can answer that question? Assume. Did I assume these three? No, I did not. No, you said I assume it. Okay. Okay. Let's know your own meaning. What's your own meaning? Okay.
Just
3. Let's say in university now, the maximum CGPA is 5. And I remember I asked that what will be the benchmark to assess good students in this school? And you said what? 3.5. You were even part of those that said 3.5. Huh? And now you're asking. Okay, so don't assume mean because you said assume or hypothesize. It has to do with a known standard somewhere. Okay, and I gave some example. I gave example of scores over 100. That if you want to assume standard there, you use 70 as a standard to assess good students. We gave example of blood pressure. If I even use BMI, 24 to what? What's that range again? Okay. We can even take the mean of that 18 to 24 and use that as what? The normal value for, normal weight, okay? Then you now take weights of as many people as you can, and you get the mean of those people's weight, or sorry, BMI, not weight, no. Then you compare that mean with what? With the normal BMI record or measurement. So you want to find out if there's significant difference between the mean of the people and that's 19 or 20 that we want to use. It's a range. You said 18 to 24. So we must get one value. So you can get the mean. You can just say 18 plus 19, up to 24 divided by the number. So you now compare. All right. Any other question? Questions? Let's take the next test there, the one on college. Test college. College has assuming of 2.5. Don't use that my hypothesis. Use the one I just gave now, not that one on the data. So we are testing college now, and the is 2.5. How did I get 2.5? Highest is 3. All right. That's why we use 2.5 as the benchmark to our good students. Three point 3.37. It's not up to 4. Okay, I think the highest for college is 4. It's still 4. It's just that nobody got 4. Unlike in high school where, we had a first class that got that 4. So the highest in that college is still 4. It's just that now the measurement is brought down. The measurement for assessing good students is reduced to 2.5. Because we have something above 3 there. You can see 3.34. So the maximum is 4. $2.5. Confirm your result with mine. Compare your result with mine. The same thing. All right. So I'll need one of us to report these results, and another should give us a detailed and comprehensive interpretation. Since yesterday, I started calling us fellow data analysts. Since yesterday. So by today, I just assume that we are already confirmed statistician. Though. It's just data analysis. There is more to being called a statistician. Something I've been reading since 19. You want to get in just 5 days? No, it's not. So it's just data analyst. Yes, anybody, any of the data analysts here that got these results. All right. Okay. Yes. T calculated. Cheat her now. It's not.
Very difficult.
Okay? When you apply it, you now collect another data. Now you want to test before you apply that new method and after. Do you have a difference? Definitely you are going to have. Right? Now, is difference significant or not? If it is significant, that means your new method, your new drug, your new fertilizer, your new teaching method is very, very what? Effective. Do you get it? Now, something must relate these two samples. I gave you the example of, picking two samples from this class now. What is relating us? You had one training, one person trained you. Now, let's look at identical twins. They look alike, the same height, the same color, everything is the same. Now you collect features from the first, the Taye, and the Kehinde. You collect what? These features, maybe height, weight, and so on. You know that there is going to be difference, no matter how. There will still be what? Slight, little difference. So is that difference a significant one or not? Then what is relating these two, these twins? What is common between them? That will make you consider using paired sample, because the condition is something must relate the two samples together. Born from the same womb. Do you get it? Now, let's say you have one farmland here, okay? Those in agric. And then you planted the same variety of seed in the same, that's two now, in the same land. The same water, the same fertilizer, sunlight, everything, you make sure that they are what? The same. Now, as they start germinating, you are going to notice that there's a little what? Difference in the rate of the growth or the yield. Now you want to test, is this difference a significant one or not? So you use what? The paired samples t-test. So this other example, what is common between these two plants that you want to compare? What is common between them? Where you planted them is common. In fact, you have so many common things. The manure, the water, the rainfall, everything was what? The same. So it's common. All right. So is there anybody that have used this? Has any of us used this test before? To test for effectiveness of a particular, teaching method, drugs, new thing. You want to test how effective it is. I think those of us in medicine, if there's anybody from medicine, okay, you use it. So the right test is the paired samples t-test. Now, the sample size must always be what? The same. Because you are pairing, okay? 1 to 1, 2 to 2, 3 to 3, the sample size must always be what? The same. If you have 10 here and another 10 here, what will be the total in sample size? I mean, in paired samples. We are about 30 now. And I have two groups. Group 1 is 10. The second group 2 is 10. What is the total? 20 is wrong. It's 10. Do you get it now? It's 10 because the two group is seen as one. It's just that it's like splitting 1 into 2. Do you get it? That's why for every one you have here, there must be a pair in the second group. It's like mommy now is number 1 in that group. You will also be what? 1. So you and mommy are seen as what? 1. Pair. Do you get it? That is why when you want to take that n will not be n1 plus n2. Okay? It will be n minus 1. Do you get it now? All right. Now let's look at the conditions. There are some very serious conditions to, just like in the first t-test we looked at, that we must meet before we use these paired samples t-tests. Dependent variable should be continuous. You see, these two groups now, these two samples, they depend on each other. And they relate to each other. There's a relationship between them. Therefore, they depend on each other. So, unlike in the independent, in fact, from the name, independent, the two groups do not depend on each other. So if you pick one sample from this class, you must go to the other class to pick the next one. But for paired, the two of them depend on what? Each other, because there is something common between them. So you must make sure that you meet this condition of what? Dependency between the pairs. All right. Okay, I've said this, that the dependent variable should relate to each other. Then you test whether the data set are normally distributed. Of course, this one we used to do that. And then you check if this one, there's a way we used to do this. There should be no outlier in the difference between the two related groups. When we start the practical, you are going to see that the way you are going to take this outlier is different. You must take what? The difference between the two groups. It is that difference that you are now going to test for outlier. It's like group 1 now and group 2. There's a difference between Oga and mommy there. Let's say the difference is 2, or let's say it's 3. Then the next man, you know, with another pair there, the difference is 4. So 3, 4, and so on. Those differences are the one you are going to subject to the normality test. Are we getting this? Supposed to have come. This one, don't know. Are we getting this? Unlike in the other case where you just go straight, you use the original data to test for normality and outlier. Here, you must take the difference between the two groups. So it's that difference that you will now test for normality. Then, and for outlier too. When one or more of the assumptions, of the paired sample t-test are not met, you may want to run the non-parametric Wilcoxon signed Ran test. That's the non-parametric alternative. If we have time tomorrow, we'll look at it, how to carry out the non-parametric alternative to all these parametric tests we are looking at today. All right. Any question on this brief background information on paired samples t-tests? I said that the two samples are drawn from the same population. Then I said that something must be common, something must relate the two samples. They must depend on each other. Okay? And I also said that the sample sizes between the two must be what? Equal. Because for every individual you pick in sample 1, it must have a pair in what? Sample 2. Therefore, you have 1 to 1, 1 to 2 to 2, 3 to 3 till you get to the last member of the group. Then we also said that the two groups are seen as one. Therefore, to take the normality test and the outlier, you must take the difference between the two groups. Is that difference that we will now test for outliers and for normality? All right. Any question? Any questions so far? If there's no question, let's go to our data, the one we wanted to use before. That data on sample. All right, let's go to our data. That first data, what's the name for that first data? Test 1, okay. All right. But I think we have to adjust this data. I can see pre and post on the data. Let's clear that pre and post. This one, let's remove it. So where you have that V1 is just the serial number. Then that 42, 28, that's the pre-test. Then where you have that V3, that's the post-test. So what we want to do now is to test whether we have a significant difference between the pre and post-test. This was one analysis we did one time. It's actually a PhD work. The researcher was trying to test how effective cooperative learning strategy and conventional teaching technique, how effective is it to passing a particular subject? Okay, so let us go and reorganize this data. That's V1. I want us to remove V1. We don't need it. Clear V1. Then, where you have that cooperative, we write pre-test there. This one, this line, it should be pre-test, while V3 will be post-test. So let's go and do that change. Cooperative is pre-test, and V3 is post. So look up to see how I changed it. No, we are still on the cooperative teaching learning strategy. So you can see the pre-test before that cooperative teaching method was used. And then after the teacher used cooperative method to teach the students, gave another test, you can see that there's an improvement in their performance. So even before we take this test, I think that cooperative teaching method is effective. From the difference, you can see the difference in their performance. So to do this test, we start by taking all those preliminary tests, all those assumptions that we need to meet, and the conditions. Assumption number one is for us to test for normality and outlier. So you start by taking the difference between post and pre. And I've taught you how to do that. Okay? So I want us to take post-test minus what? Pre-test. Let the score come at the next column. You can call it difference between pre and post. All right, let's start, please. Take the difference between post-test and pre-test. Take the difference between post-test and pre-test. Can we remember? Who can remind us? Because I can see some of us doing something else. Huh? Where do we start from? Analyze. No. Transform. You go to transform. I'm sure when you hear transform now, you know what to do next. Don't do pre-test minus post-test. It's post minus pre. Any results? Who has finished? Nobody. We are forgotten. Just agree that you are forgotten so that we don't waste our time. Have you done it? Hmm? I mean, something is wrong with your computation. Let me remind you. Let me remind you. Just relax. Nobody said you should transform. Good question. Why are we finding the difference? Who can respond to that question? It's a very good question. Why are we taking the difference between post and pre? I'm not the one that said it. That is the assumption, the condition. I'm not the one that said it. Don't quote me and say that's what I said. Go and read about it. You see that is the law. That is the condition, the requirements. That you take the difference between the two groups. When you take that difference, you test that difference for normality and for outliers. And I ask us to take difference. We have all forgotten. Let me remind you then. Oh, I should not remind you. I should give you time to do it. All right, let me give you time to do it. Go to, please, let's go to variable view. Let me help you out. Even he got his too. Go to variable view and change your the type of variable there. Change it from string to numeric. Because S students taught using those all about. No, I want us to state it in this form. Those students taught using through the, well, let's leave that one. It's not our work. So, all right. We said H naught, there is no significant difference between the pre and post cooperative learning test score. All right. Level of significance is 0.05 as usual. Then to take the test, we start from analyze, we go to compare means. From compare means, we go down to paired samples t-test. So. From analyze to compare means, from compare means to paired samples t-test. Then we click on it. When you click on it, we have this dialog box. Let's move posts to variable 1, pre to variable 2. Yes, ma'am. Anywhere, you can place it anywhere. My fear is I'm trying to avoid negative. Because if I pick, I think usually it used to be variable 1 minus 2. I'm not sure, but I think that is the way SPSS will take that difference. So if you want to take variable 1 minus 2, I want it to be post-test minus pre-test so that we don't have negative difference. And you take it first. All right. So that's all you need. You will end by clicking OK. And you have your results. All right, so we have this result. Let's report the important results here, and then we interpret. The mean pretest score equals 38.4. The mean pre-test score equals 38.4, while the mean post-test score equals 76.8. Sample size equals 191. The mean gain, there's something like that we call mean gain here. Whenever we take this analysis, some people call it mean effect. Some call it mean gain. Some call it mean achievement. What is the gain from using that teaching method? what is the mean effect of using that teaching method? Or what is the mean achievement of using the new method? So whichever grammar you want to use there, the mean gain here is what? 38.5. Have you seen it? 38.5. T calculated. T calculated is 33.8. Degree of freedom equals n minus 1 equals 191 minus 1 equals 190. DF, degree of freedom, equals n minus 1, 191 minus 1 equals 190. And p-value equals 0.000. So most times you just check to see the other figures after the zero, so that we don't just keep leaving 0.00. Double click on the 00. All right. All right, let's interpret. The cooperative learning method is highly effective because the mean gain after teaching the students biology using cooperative learning method is 38.5. The mean, yes. The mean gain or effect of teaching, no, that's not how the cooperative learning method is highly effective because the mean gain after teaching the students using cooperative learning method equals 38.5. 38.5. So we stop there because that is just like a descriptive, interpretation. We're just looking at the mean difference between the post and the pre. So now we go to the p-value. Since p-value equals to 0.00 is less than, since p-value equals 0.00 is less than level of significance equals 0.05. The null hypothesis is rejected. The null hypothesis is rejected. And the alternative accepted. And the alternative hypothesis is accepted. We therefore conclude that there is a significant difference we therefore conclude that there is a significant difference between the pre and post cooperative learning strategy scores. Can we just discuss about these results? Is there anybody that have anything to add to these results? Like further, explanation to these results? Though what I noticed is, as a statistician, we did a lot in the interpretation, right? If you notice, we did a lot. Because now we have established that the cooperative learning strategy is very effective. And it has a significant effect on the students' learning process. Okay? So even if we don't add any, maybe the only thing you can just add is if there is previous work on this to support or to go against it, that's all. If not, we've done the major work by establishing the fact that cooperative learning has a high effect on students' performance. You can see that the difference was what? Very, very effective. I mean, very high or very significant. You can use that word, very significant. And the mean gain is also very high. Okay, so the summary of the whole thing is that learning method is very, very effective. So teachers will now be advised to always use that particular learning method. All right. Okay, any question on this? Any question? If there's no question, then we'll take our first break, the tea break for 30 minutes. When we return, we will go straight to the independent samples t-test. Independent samples t-tests. I'm sure most people use that test, where you pick 2 samples from 2 populations. It's not like this one that you pick 2 from 1. What can those guys do?